Today I want to talk about sequences in series. And so to do that, we will open up our notes and talk about it. And so we have a few objectives. Sequences in series. The idea is we want to learn how to use sequence notation to write the terms of sequence. We want to learn how to use factorial notation. We want to learn how to use summation notation, and we want to learn how to find sums of infinite sequences or series. And also, we want to learn how to use sequences and series to model our real-life equations. Next page. When we think of a sequence, we think of something that has to have an order. So sequences have two major properties. Sequence is anything that can be collected in terms of an order. For example, like when you're going to have a competition, you have a first place, second place, and a third place. Same principle in sequences. We have a first term, we have a second term, we have a third term. Okay, it has an order. The difference is that with a sequence, we have a way to develop a pattern. Okay. We can develop this pattern in some way, shape, or form. We can have also the sequence not end or be infinite, and we can have the sequence be finite and end. Okay. Simple enough. Let's start drawing. So the first thing let's talk about is sequential notation. How do we denote a sequence? A sequence okay. We normally use the letters. Letter A, we have A sub 1 for first term, A sub 2 for second term, A3 for third term, all the way to A sub n. And this is, of course, for a finite sequence. And we have the same but it continues on for an infinite sequence. Okay. And the values of A can be any number. Usually, it doesn't have to necessarily be an integer. It can be fraction, it can be rational number, it can be irrational number for even. But as long as there's a way to develop the sequence, you can use these terms. Okay. And of course, sometimes we use A0 for the first term. So you can also see that as well. When we use in real life situations, we use A sub 0 for the first term for being at time being 0. For example, something like that. Okay. So with that, we have to have a way to develop the sequence. And so we develop the sequence with a given pattern of some type. So, for example, okay, example, find first 4 terms of the following sequence. We have a sub n, which is our definition of our sequence. A sub n equals 3n plus 1. And so we want to define it for the first 4 terms. So that means a1, a2, a3, and a4. So simply put, we plug in 1, 2, 3, 4 for our n. So we plug in a sub 1 is equal to 3 times 1 plus 1, which is of course 4. A2 is equal to 3 times 2 plus 1, which is of course 7. A sub 3 is equal to 3 times 3 plus 1, which is of course 10. And lastly, it's 13. A4 is equal to 3 times 4 plus 1, which is of course 13. Okay. So does that make sense? The idea being that to develop a sequence, we have to have a way to develop it. This is our definition of our sequence. We plug in numbers to figure out how many there are. We plug in the different n's to figure out what the numbers will be in the sequence. So if we were to write this sequence out, it would become like this: 4, 7, 10, 13. And I'll put ... to continue it on because I don't know whether it's going to end or not. Okay, it's an infinite style. For the next example, I want to do one that alternates sign. Okay. So to have an alternating sign sequence, something like that. Okay. So once again, we figure out the solution by plugging in 1 through 4, obviously. To get each term of the sequence. So in this first situation, we have a sub 1 is equal to negative 1 to the first over 3 times 1 minus 1. Negative 1 to the first power is, of course, negative 1. And 3 minus 1 is, of course, 2. So that will be negative 1 half. A sub 2, negative 1 to the 2 over 3 to the 2 minus 1. Negative anything squared is 1. Positive 3 minus 6 minus 1 is 5. And then a sub 3 is, of course, negative 1/8. And then a4, negative 1 to the 4th. 3 times 4 minus 1 equals 1/11. So to write out the terms of the sequence, we'll write it on the next page. It's negative 1/2, 1/5, negative 1/8, 1/11, ... And the signs alternate from positive to negative. And as you knew, negative 1 to the odd power is always odd, is always going to be negative 1. Negative 1 to the even power. This is a little trick that if you guys don't know it, you ought to know it. And it's odd, negative 1. And it's positive 1. If you guys don't know that, you should know that, because that's a very simple trick to know. Okay. The next thing to figure out is, of course, the nth term of the sequence. So now that you know kind of how to go forwards with this process, let's go backwards. So to go backwards, and you're given the sequence, and you need to figure out how the pattern developed. So okay. Find the nth term for the 2, 4, 6, and 8 situation. Okay. So the solution to that in this situation at n equals 1, so we have n, and then a of n. You can draw out this little table like this. 1, 2, 3, 4, 2, 4, 6, 8. Obviously here you can see that the sequence is twice n. There's more than one way to write this sequence actually. So you can write, you can see that to get this one to this one, it's everything being multiplied by 2. So you could simply say a sub n is equal to twice n, and be correct. You could also say okay, this is the correct answer. There's of course more than one way to write this. You could write this in a number of different ways to define the sequence. Right? If I'm calling this an arithmetic sequence, it's being added each by 2. We'll talk about that more in detail in a minute. This is plus 2, plus 2, plus 2. You could also define it to be you could also define it to be you could also define the same sequence 2n plus 2, and you could define it at n equals 0. But that would be defined for at n equals 0 instead of n equals 1 like this one. This is defined at n equals 1. The other is defined at n equals 0. But hey, that doesn't really matter. But in this case, you can either write it as either one, but we won't worry so much about that necessarily. And we'll see as to why this one is correct versus this one. Okay. Okay. So just define it as this and you'll be okay. And I'm going to stop talking here, and we'll continue in a couple of minutes after you guys do this example here. Okay, so I'll stop talking.